This is part 2 for the district's final study guide. So this is the circles and then transformations and then volumes. So we want to find the value of x. We got to start with what we have, though. We have the measure of arc CD, which is 35. One thing we want to look for here are semicircles, and we do have a semicircle. Here's a semicircle. It's half a circle. The measure of a semicircle is 180 degrees. So we can do 180 minus 35, okay, which is going to give us 145. So the measure of arc AC is going to be 145. We know that since the vertex of x, this angle here is the center, it's a central angle, and we know the measure of a central angle is going to be equal to the measure of the intercepted arc, so it's going to be 145. Okay, number 2. The trick here is realizing that you have radiuses, radii. So there are 4 radiuses. We know all those radiuses are going to be the same length. The radius of a circle is going to be the same no matter what point you're connecting the center to. So we are going to have side similarity. So we have similar triangles there. So if we have similar triangles, we know the corresponding angles are congruent. So if this angle is 100, this one is also going to be 100. Or a little bigger, maybe. We also notice we have an isosceles triangle. 2 sides are the same length, so we have an isosceles triangle, so the 2 base angles are the same. So if this is x, this one's also x. And then we had 2 ways we solved for x here, for that angle. The first way is we knew these 3 added up to 180, so we did 180 minus 100, which gave us 80. And we knew these 2 had to add up to 80, and we knew where they were the same, so we divided by 2 and got 40. The other way we set this up is we just set up more of an equation. So we knew the 3 angles add up to 180, so we did x plus 100 equals 180. You get 2x plus 100 equals 180. Subtract 100. 2x is going to be equal to 80. And then we divide both sides by 2, and we get x equals 40. So either way, we get 40. So the trick was realizing we have 4 radiuses. Those are all the same. So that one's 100. This one's also 100. It's isosceles, so those are both going to be the same. 40 and 40. 40 plus 40 plus 100 is 180. 3 and 4. It tells us EF and GF are tangent lines to the circle H. If we have tangent lines that intersect a radius, we know they're going to be perpendicular. So tangent line and radiuses are going to be perpendicular, which means they're going to form right angles. So we have 90 and 90. And then we have a quadrilateral. We know the 4 angles of a quadrilateral add up to 360. So again, we can do 360 minus 140 minus 90 minus 90, which is going to give us 40. Okay. Or we could do 90 plus 140 plus 90 plus x equals 360. And then we would get 320 plus x. All right, combine like terms. Subtract 320 and we get x equals 4. Over here, they're not telling us they're tangent lines, so we can't assume they're tangent lines, but we do have an isosceles triangle. So if that's 70, right, we don't know if the radius and this line are perpendicular, so we can't assume it's a tangent line. But we do know that angle is 70, so we also know this one's 70 because it's an isosceles triangle. 2 sides are the same length, so the base angles are the same. So we know 180 minus 70 is going to give us 40 again. Or we do 70 plus x equals 1. So 140 plus x. Five and 6. find x here for 5 and 6. Let's just do this. Okay. So there's a quick way to do this. We didn't talk about this, but if you have two segments, two chords of a circle, and they meet, they start at the endpoints of a diameter and they meet somewhere, they're going to form a right angle. So we do know this is going to be a right angle. We do know that's going to be 90 degrees. So we can do 180 minus 90 minus 15 to get our answer. But the way we've been doing this is using the fact that these are inscribed angles. So here's an inscribed angle. The measure of the intercepted arc is going to be double the measure of the inscribed angle. So this is 30. And then here we have a semicircle. Measure of semicircle is 180. So if we do 180 minus 30, we get 150. Right, so the measure of this arc is 150. And then here we have another inscribed angle. The measure of an inscribed angle is half the measure of the intercepted arc. So we take half of 150, which is 75. Next one, the measure of AC is 130. We need to look for semicircles. Here's a semicircle. The measure of semicircle is 180. So 180 minus 130 is 50. So we know the measure of arc CD here is 50. We also notice x, which we're trying to solve for, is an inscribed angle. So the measure of an inscribed angle is half the measure of the arc. So this is going to be 25. Okay, x is going to be 25. Half of 50. Because it's an inscribed angle. Number 7, 8, 9, 10 here ask us to use 6 to answer questions 7 through 10. So we need to name a radius. A radius is going from the center of the circle to a point on the circle. So the circle is made up of an infinite amount of points that go around at a fixed distance. So the points that are labeled, there's an infinite amount of points, but the points that are labeled on the circle are A, C, and D. So a radius goes from the center to one of those points. So you can name BA, BC, or BD. So any of those would work. I'm just going to put BA, segment BA. A chord is a segment that connects 2 points on the circle. So again, the 3 points we have labeled on the circle are A, C, and D. So a chord, the two that are drawn are AC and AD. So AC or AD. AC would work there for us. Okay, diameter is also a chord, but it's a chord that goes through the center of the circle. So the center of the circle is B. So again, there are two chords here, AC or AD. The diameter is the chord that goes through the center. So the one that goes to the center is AD. AD. And the last one, name an arc. We got minor arcs, semicircles, major arcs. But we can just say, how about arc AC? Okay, and we put the little line over it. For arc AC. So BA, AC, AD, and then arc AC. There's a minor arc. You could also do major arc. Okay, we want to find the area of a sector with a central angle of 70 degrees and a radius of 10 feet. Okay. So central angle is 70, so our area is going to be 70 over 360. Right? 70 is the angle. Take the measure of the angle to find the length or the area of the section. So it's 70 over 360 times pi, and the radius is 10, so 10 squared. Pi r squared is this is the area of the whole circle. We don't want the area of the whole circle. We only want 70 out of 360. So that's 100. So 7,000 over 360. Well, we'll get a decimal. So 70 times 100. So we're going to get 19.44 pi, which is approximately 61.1 feet squared. So um, 12, if the area of the circle is 480 pi inches squared, find the circumference. So again, we're using both area and circumference formulas here. So area is pi r squared, circumference is 2 pi r. We are looking for the circumference. In order to find the circumference, we need the radius. We don't have it yet, so we need to find it. We need to use the area to find it. So we know the area is 480 pi. So 480 pi is going to equal pi r squared. We can divide both sides by pi, and we get 480 equals r squared. We want to find the radius, so we need to get r by itself, so we need to get rid of the square. To get rid of a square, we take the square root. This is going to be 21.9 equals the radius, so then we can find our circumference. 2 pi, 21.9. Okay, I'm not going to leave pi in there just because it's not going to be an even nice number. So times 2 pi, and we get 137.7 inches. Okay. 13. So we want to write the equation of the circle below. So we need to find the center and the radius. Okay, so the center of our circle is going to be negative 5, 3. We just find the coordinate here. So center is negative 5, 3. The radius we just count. So you go up, down, left, to right. So 1, 2, 3, 4, 5, 6. So the radius is 6 units. Again, if you went this way, it would work too. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The circle is 6 units away from the center. Our formula for a circle is x minus h squared plus y minus k squared equals r squared. So x minus the negative 5 is going to be x plus 5. Y, right, this is h and k. H is negative 5, k is 3. Y minus 3 squared equals 6 squared. We know 6 squared is 36. So here's our equation for our circle. Just flip the signs. Negative 5 becomes plus 5, 3 becomes negative 3, and then we square our radius. 6 times 6 is 36. Arc length. So we have 2 circles here we want to find the arc length of, and then one we want to find the sector area of. The formula for arc length is x over 360 times 2 pi r. So the measure of our arc is 270, so that's going to be 270 over 360 times 2 pi, and the radius here is 13 feet. So 270 over 360, that's 3/4 times 2 times 13 times pi. 61.3 feet. Okay, and then our next one, again, same thing, arc length is going to be, in this case, it's going to be 315 over 360 times 2 pi times 11. So 315 divided by 360 times 2 times pi times 11. 60.5. Okay, so we don't want the circumference, right? 2 pi r, 2 pi times 11 is the circumference. We don't want the whole circumference. We only want 270 out of 360 and 315 out of 360. Okay, 15 is sector area. Okay, sector area is very similar, except instead of multiplying by the circumference, we multiply by the area of the circle. So we don't want the whole area, we just want the area of this piece of it. So that's going to be x over 360 times pi r squared. So that's going to be 150 is our arc measure. And then our radius is 3 times 3 squared. Okay, so 150 divided by 360 times pi times 3 squared. I got 11.8. This is 11.8. Units are meters squared. Last slide here, so we're on to transformations and then volumes. So this one we want to translate 2 units down and 5 units to the 2 units to the left and 5 units down. And so we want to write the rule first. So our rule here is going to be x comma y. Okay, and then we're going to, x is going to get mapped to x minus 2, right? It's left, so we're going minus 2. And y is going down, so y is going to get mapped to y minus 5. We can find all these points and plug them in, or we can just count. So we're going 2 left and 5 down. 1, 2 left, and then down 5. 1, 2, 3, 4, 5. So here is B prime. To the left, 1, 2, 3, 4, 5 down. Here's I prime. 1 to the left, 1, 2, 3, 4, 5 down. That's V prime. 1 to the left, and then 1, 2, 3, 4, 5 down is C prime. So here is our translated figure. Everything is 2 to the left, 5 down. Okay, we want to reflect across the x-axis. So here's our x-axis. Again, 2 ways to do this. We can write the points out and use our rule. Our rule for the x-axis is AB goes to A negative B. Or we can just count. So we're going over the x-axis. So C prime is going to stay the same. I is 2 units up, so we want I prime is going to be 2 units down. 3 units up is B, so B prime is going to be 3 units down. V is 3 units up, so V prime is also going to be 3 units down. Okay, for hard time visualizing that, we can write out the points. So our C was 3, 0. I was 2, 2. B was 2, 3. V was 4, 3. Okay, and our rule again is AB goes to A negative B or A opposite of B. So 3, 0 becomes 3, negative 0, which is just 3, 0. This becomes 2, negative 2, 2, negative 3, and 4, negative 3, which is what we had. And then we could plot these points, but those are going to be those points already. We're rotating 90 degrees counterclockwise. Getting out. Having some copy issues here. That image is cut off as well, right? All right, so 3, rotating 90 degrees counterclockwise. Okay, so first thing, a rule for 90 degrees is AB goes to plus or minus B plus or minus A. We don't know. Okay. So let's list our points. We have 3, 0. C is 3, 0. V is 4, 3. Okay, I is 2, 2. And B is 2, 3. 2 steps to rotating 90 degrees. First is you want to flip them, the coordinates. And 2 is you want to find the signs. So let's just do step 1 first. So we want to flip them. So this is going to be 0, 3. This is going to be 3, 4. This is going to be 2, 2. And this one's going to be 3, 2. And then we got to figure out what signs these are. So if we're rotating counterclockwise 90 degrees, we're going to go from quadrant 1 into quadrant 2. The signs for quadrant 2 are negative, positive. So I, B, and V, okay, are all going to become negative, positive. So negative 3, 4, negative 2, 2, negative 3, 2. 0, 3 is on the x-axis, so when you wrote 90 degrees counterclockwise, it's going to end up being on the y-axis, the positive side of the y-axis, so it's going to be 0, positive 3. So this is going to be C prime, and then we can plot our other points. V prime is negative 3, 4. V prime. Negative 2, 2 is I prime. And then B prime is negative 3, negative 2. So this is B prime. Okay, so it's rotated 90 degrees this way. Okay, we want to dilate the figure by a scale factor of 2. Let's just try to finish off this graph here. Okay, 1, 1 should be here. That's A. Negative 2 zeros here. That is B. And then C is 2, negative 1. So that should be somewhere like right here. Let's see. Okay. So dilation by a scale factor of 2. So 1, 1 is going to go to, we're going to multiply by 2. So we're going to go to 2, 2. Negative 2, 0 is going to go to negative 4, 0. And then 2, negative 1 is going to go to 4, negative 2. So A prime is going to be here at 2, 2. B prime is going to be here at negative 4, 0. And then C prime is going to be at 4, negative 2, which will be down here somewhere. Okay, so our new image is going to be like something like that. It's getting bigger. Every point is getting farther away from the origin by a factor of 2. Okay, 5, 6, and 7. So 5, what are the new coordinates of A, B, and C when it's reflected over the x-axis? So the rule for the x-axis is AB goes to a negative B. And if you need to graph it out, that's fine. Go ahead and graph it out and see where they go. But all we need to do is switch the signs on the y-coordinate, because if we're flipping over the x-axis, okay, this is the x-axis, so if the point's here, it's just going down. So all that's changing is the y value. It's down here, it's going up here. All that's changing is the y value. So negative 3, 7 is going to go to negative 3, negative 7. 5, 1 is going to go to 5, negative 1. 6, 0 is going to go to 6, negative 0, which is just 0. Y-axis, all that's changing is the x value. AB is going to go to negative AB. So if you're flipping over the y-axis, the y value is staying the same as the x value that's going to flip from positive to negative or negative to positive. So negative 3, 7 is going to become 3, 7. 5, 1 is going to become negative 5. And 6, 0 is going to become negative 6, 0. Graph it out if you need to. A figure has been translated 4 units down and 3 units to the left. How would you describe the transformation? Okay, so our rule here is we're going 4 down, so that's y minus 4. And we're going 3 left, so that's going to be x minus 3. Use your rule to find the new coordinates of the figure. A, B, and C. So 4a is 4, -1. Okay, so that's going to be 4 minus 3. And then -1 minus 4. Okay, which is going to give us 1, -5. So A is going to become 1, -5. You're going 3 to the left, 4 down. If you need to graph it out, go ahead and graph it out. B is 2, -3. So we're going 3 to the left, 4 down. So that's 3 to the left is going to put us at -1. 4 down is going to put us at -7. Okay, then C is -2, 5. So we go 3 to the left, we're going to be at -5. We go 4 down, we're going to do 5 minus 4 is 1. So -2 minus 3 is -5. 5 minus 4 is 1. Okay, 7 is just like 5 up here. We're reflecting over the x and then the y-axis. So again, x-axis is going to be AB. This looks like the exact same problem. It is the exact same problem. Is it the same way on here? Yes, it is. So we just already did 7. Same as 5. But try it again without looking at 5. Now we're on the last part here, which is volumes. And again, 2 of mine are cut off. 5 and 6 are cut off here, but that's all right. We got 9 volume problems here. So the volume of a rectangular prism, and is the area of all prisms, is the area of the base times the height. Well, we know the area of the base is a rectangle, so area for a rectangle is length times width. So you can either find the area of the rectangle and then multiply by the height, or we can just put it in here, and we get length times width times height, which is 5 times 6 times 8. So that's 30 times 8, which is 240. All right, and we're going to put units cubed, just because it's not giving us units. Okay, here we have a triangular prism. So we need to find the area. So it's a prism, so our volume is area of the base times the height. Okay. We know the area of the base is a triangle, so it's going to be 1/2 base times height. Okay, and we don't want to confuse. This is the height of the triangle. That's the height of the prism. So the height of the prism is the distance between the two bases. So the bases are the triangles. So we want to find the area of one of the triangles. In order to do that, we need the base and the height. So they're giving us the hypotenuse here. We're going to want 12 and x here. Okay, so to find 12 and x, we're going to have to use the Pythagorean Theorem. Okay, so 12 squared plus x squared equals 20 squared. So that's 144 plus x squared equals 400. Subtract 144 from both sides. X squared is going to be equal to, that's 256. Squared both sides, we're going to x equals 16. So it's going to be 1/2, 12 times 16 is the area of the triangle. So that's going to be 96. Okay. So the area of the base, the area of the triangle is 96. Okay, the height is the distance between the two triangles, which is 10. So our volume is 960 units cubed. Number 3 here. Right, so again, we have a triangular prism. So it's a prism. So our volume is the area of the base times the height. The base are the triangles. Okay, so we're going to have to use, I don't think we want to do this one. We definitely don't want to do 4. We're not going to do 4. Don't worry about 4. I think we're going to skip 3 as well. Yeah, let's skip 3 too. Yeah, let's skip 3 as well. I don't think I want to do that. No. Yeah, let's skip 3. So let's go to 5 and 6. So skip 3 and skip 4 on the review. Sorry if you wasted some time on it. That's fine. Whatever. It's not on the final. We're good. Let's go to 5 and 6. Okay, they're not on here. They got cut off for me, but you guys can see them. So 5 is a cube. So if we want to find the volume of a cube is a rectangular prism. So again, it's the volume. This is 5. Okay. The volume of the cube is going to be equal to the base of the cube times its height. Again, the base of the cube is the square or the rectangle, and the area there is going to be length times width. So we know the volume is length times width times height. So we're going to have 4 root 3 times 4 root 3 times 4 root 3. Okay. 16 times 3, 48. 48 times 4, 192 times the square root of 3. And again, let's just put units cubed. And the next one is a cylinder. So the volume of a cylinder is also the area of the base times the height. The base of a cylinder is a circle. So the area for the circle is pi r squared. So we get pi r squared times height. Okay, we know the radius. They give us the diameter of 12. So we know the radius is half the diameter. So we know the radius is 6. And they give us a height of 25. So we get pi times 6 squared times 25. So 6 squared is 36. 36 times 25 is going to give us 900 pi, which is approximately 2,827.4 units cubed. So then we got 3 more here. 7, 8, or just 7. Find the volume of each of these. So we have 2 cylinders and a rectangular prism. Okay. So first one is a cylinder. So again, cylinder, volume equals the area of the base times the height. Cylinder, the base is a circle, so it's going to be pi r squared h. So pi, the radius here is 8. The height is the distance between the 2 circles, which is 20. And we just put that in our calculator here. So 8 squared is 64, so 64 times 20 is going to give us 1280 pi. You can multiply the pi out if you would like. I'm just going to leave it there. And then it's going to be centimeters cubed. Okay, and that should be approximately 4,021.2 centimeters cubed. Rectangular prism, volume is the area of the base times the height. We know the base is a rectangle, so we know it's going to be length times width times height. Okay, so it's going to be 15 times 10 times 5. Okay, so 15 times 10 is 150 times 5. It's going to give us 750. They don't give us units, so it's just going to be 750 units cubed. Okay, then last one here is a cylinder. So volume is the area of the base times the height. We know the base is a circle, so the area of a circle is pi r squared. So we have pi r squared times the height. Volume is pi 6 squared, and the height is 11. So that's 36 times 11, which is 396 pi meters cubed. Okay, if you multiply the pi out, it would have been 1,244.1 meters cubed. Okay, so that is part 2. It's a bit shorter than part 1, which is good. I don't think anything on there is too challenging. We're definitely not doing the trapezoid prism. We're good on the other one. So, yep.